The digital memory storage and bit shifting characteristics of the shift register is essential in many digital electronic systems. The keying of numbers into a calculator demonstrates the practical application of a shift register. As numbers are entered, they are stored and displayed. Each subsequent number that is entered shifts the previously entered number to the left. Let's look at how a shift register operates by observing the shifting of an 8-bit register based on a series of binary data inputs. We have two serial inputs, D1 and D2, arriving at an AND logic gate. A master reset input at MR, which when activated by a low or zero input, will override all other inputs and reset the Q1 through Q7 outputs to 0. A clock pulse input, CP, which will be enabled when transitioning from low to high. The right-pointing triangle symbol without the bubble signifies this clocking functionality. Let's input the binary data at D1 and D2. With an AND gate, when both inputs are high, the output is high, and conversely, when either inputs are low, the output will be low. At T1, the 0, or low, at MR, overrides the D1 and D2 inputs and sets all outputs to 0. At time T2, D1 and D2 are high, or 1. Thus, the output at Q0 is 1. This information bit is placed in the Q0 position in the register. This shifts the other bits one place to the right. At T3, the input of 0 at D1 and 1 at D2 results in an output at Q0 of 0. The 0 at Q0 replaces the 1, again shifting all the bits one position to the right. The 0 and 0 input at T4 again outputs a 0, which drops into the Q0 position, shifting the bits again to the right. At T5, the input of 1 outputs a 1 that drops into the Q0 position, with the bits shifting again. The inputs at T6 produce another output of 1, which shifts the bits again. This continues for clock pulse T7 and T8, with the inputs at T7 and T8 resulting in zeros at output Q0. This input into the register continues to shift bits to the right.